Afternoon, everybody. Good afternoon, everybody. I would like to welcome you to this Insala webinar, Honoring the Bitterroot, Traditional Knowledge, Science Education, and Intrinsic Motivation. Our presenter today is Rose Honey. She is a doctoral candidate at the Harvard Graduate School of Education. And Ms. Honey is going to be talking to us today about some of her work with the Salish and Penderoy students on the Flathead Indian Reservation in Montana. We're going to have some time to pause during her presentation for questions. If you have any questions, I'd like to ask you to direct them through the chat window, which you're going to see on the left-hand side of your screen. It's about the middle of the screen there. So if you have any questions, go ahead and direct them through the chat window, and we will pause for questions, and I will deliver the questions to Ms. Honey during the question period. So Rose, I'd like to thank you for presenting here today with Insala, and welcome, and please tell us more about your work.
Thank you, Kira. I just want to thank everybody for taking the time to listen to my presentation today. I'm excited that so many people are interested in my work. The focus of the webinar today is going to be about the dissertation study that I'm currently doing, which explores intrinsic motivation for students who live on the Flathead Indian Reservation in western Montana, as Kira said. And I'm looking at students who learn culturally relevant content in their science classrooms, and I'm exploring how this may relate to how they think and talk about cultural knowledge in relation to their science lessons in school. So like Kira said, my name's Rose Honey. I grew up in Darby, Montana, and I currently live in Missoula, Montana. So Darby is just about an hour south of Missoula, for those of you that aren't familiar. I have a bachelor's degree in physics from the University of Oregon and a master's degree in the Mind, Brain, and Education program from Harvard Graduate School of Education. And I'm currently a doctoral candidate at the Harvard Graduate School of Education. My study with the students on the Flathead Reservation started in the spring of 2011, so about a year and a half ago. And I plan to graduate this coming May, so I'm currently writing up everything and still analyzing the data. I'm going to give you some of the preliminary results, but I'm still in the middle of all of that analyzation process. So just to give you a little overview of the presentation today, first I'm going to give you a brief overview of traditional knowledge and how I see it as relating to science education, and what is being done to implement culturally competent pedagogy in the state of Montana. Second, for my qualifying paper, which is similar to comps for a lot of doctoral students, I did a literature review on all the studies that I could find that were focused on indigenous science education in North America, so studies that were focusing on students in the United States, Canada, and Mexico. And I'm going to point out some of the key findings from this literature review that may be of interest to you and relevant to some of the work that you're all currently doing. Third, I'll introduce my study and talk about why I chose to focus on intrinsic motivation. Then I'm going to talk a little bit about the participants of my study and what I did to make my survey instrument culturally sensitive and relevant to the community that I'm working with. Last, I'm going to talk a little bit, as I said, about the preliminary quantitative and qualitative results of my study. And due to time constraints, I'm not able to go too deeply into any of these topics, but of course I welcome questions in the middle and at the end of this presentation, as well as you're welcome to contact me later. Some of you have already emailed me. I haven't had a chance to get back to you, but if anyone would like to have a conversation in the future, I would welcome it. The bitterroot plant was once a staple food for Native American peoples in northwestern America. The Salish Penderoy people on the Flathead Reservation tell a story about how the bitterroot plant came to their people during a time of starvation. They hold a ceremony to welcome what they call the first visitor each year. So they call the plants visitors. And the youngest girl in the tribe digs up the first bitterroot plant of the season. And then a woman elder blesses the bitterroot as she peels it and shows how to take the heart out of the plant, which you can see in the picture. And so she's taking the heart out of the visitor, which is the seed, and puts it back into the earth. And this signifies the start, this signifies the start of the bitterroot digging season and concludes with a feast. So the story of the bitterroot is an example of how traditional knowledge and scientific knowledge can overlap. The bitterroot plant is honored and valued in this community, but there's real science behind why it is important to these people. So some of the medicinal qualities you can see listed here include increasing milk production while nursing infants, purifying blood, clearing skin conditions, helping with diabetes symptoms, and settling an upset stomach. Traditional knowledge, traditional ecological knowledge, indigenous science, native science, traditional ways of knowing. These are all terms that are used to describe what Gregory Kahete defines as that body of traditional environmental and cultural knowledge that is unique to a group of people and that has served to sustain those people through generations of living within a distinct bioregion. Traditional knowledge is rooted in observations made over thousands of years, shared over generations, and valued by a particular cultural group. These perceptions can be different for different indigenous groups and different cultures around the world who hold different kinds of knowledge and interpretations of their surroundings. Some examples of traditional knowledge might include medicinal plant uses, like we were just talking about the bitterroot, animal and plant growth cycles and interrelationships between different species, cosmology and star knowledge, knowledge of weather patterns, and technology and knowledge of the physics of building different tools and shelter. So how is traditional knowledge related to science education? Many scholars posit that culturally relevant education is a necessary step towards providing equal opportunities for all children, and that incorporating culture into academic lessons will help students feel more connected to their coursework and increase their likelihood of success. This goes for science education too. To improve teaching and learning in science education, we must accept and understand that the content being taught and learned is fundamentally cultural. The study of Western science requires that students have some understanding of the approaches that Western science adopts in order to understand and explain the universe, specifically through theories, models, and laws. However, indigenous peoples may not necessarily understand nor subscribe to the Western scientific worldview. Many scholars are thus beginning to value indigenous ways of knowing and speculate that in order for science education to become truly culturally relevant, it needs to be more culturally inclusive. So how is cultural relevance being implemented in the science classroom? The state of Montana mandates that K through 12 educators teach about the distinct and unique heritage of American Indians in all subjects. This is called Indian Education for All, and in 2005, Montana's Office of Public Instruction created a division for Indian education, which develops educational materials and offers professional development for teachers. In addition to this, Native communities, such as the one I'm working with, are producing local materials like this book. It's called Bull Trout's Gift, which teaches students about the value of balance in nature and the idea of reciprocity. There are additional programs that provide professional development for teachers focused specifically on science education, such as the Big Sky Science Partnership. The Big Sky Science Partnership was a 5-year NSF-funded program. It's over now, it just ended. But it was aimed at improving science achievement for American Indian students in grades 3 through 8. It involved educators from the Flathead Reservation, Northern Cheyenne Reservation, Crow Reservation, Missoula area schools, Salish Kootenai College, which is a tribal college on the Flathead Reservation, the University of Montana, and Montana State University. Through summer institutes, tribal culture camps, workshops, online courses, and partnerships with tribal representatives, teachers learned cultural and scientific content within local tribal contexts. And they also focus on teaching interventions such as focusing on social construction of content, including allowing students time to individually process information in their classroom, and then moving them on into small groups where they could discuss the information, and then eventually just having a larger discussion with the whole classroom. There was also a focus on learning how to talk about the real-life applications of science in their communities. These long-term partnerships and courses worked to strengthen content knowledge and cultural competency in science education. And some of the teachers I'm working with, I know, meet with elders still, even though the program ended a little while ago. They're still meeting with elders on a regular basis. One has coffee with an elder once a week, and she's learning more cultural information and learning new ways to apply it in her classroom. Next, I'm going to summarize some of the findings from a literature review that I did, the one that I talked about for my qualifying paper. And again, I looked at research that has been done with Indigenous students in North America, specifically focused on culturally relevant science education. So I'm going to just give you a sort of summary of some of the findings. The first one focuses on context. Students may change how they value or talk about knowledge in different contexts, so context really matters. In addition, they may change how they respond in a classroom because of what they think their teacher values or what they think that their teacher thinks is right. One study demonstrated that Menominee students agreed that an elder would say that rocks and water are alive, but that a science teacher would not. So that's going to change how they do their coursework and how they interact in class. Language is important. Language can be a huge barrier for students as well as teachers, and teachers can be more effective when first language is allowed in the classroom. It's also helpful if teachers show an interest in the language and learn a few words or phrases of the local language. Student-teacher relationships are very important, and teacher ethnicity can change how teachers relate to students, thus changing student performance. One researcher promotes the use of educators who are from the same tribe and or community as the students, but we know that this isn't always possible. And this particular researcher suggests that the teachers that are not from that community or from the tribe have intensive training that is focused on cultural understanding in the community. Local focus. When materials are developed for broad populations of American Indian students, they are not very successful. This is because traditional knowledge for one local culture may not parallel local cultural knowledge in another. Culturally relevant education may result in higher achievement and more positive attitudes for one group of students, as Matthews and Smith found, but then a decline for students from a different tribe. Assumptions. Educators need to be careful about assumptions that they make about cultural content, as well as assumptions about their students. So being Yupik doesn't make one a kayaker, just as being Swiss does not make one an expert in clockmaking or banking. Educators also need to be aware of the terminology that they use when referring to culture and traditional knowledge. For example, one study that I read, even though it was supporting culturally integrated education, it labeled traditional knowledge as folklore, which can indicate that it's not believable or not respected. And the last point I want to make about findings from the literature is giving students space and time to talk. So discussing the intersections, interactions, and contradictions that exist between culture and science is really important for Indigenous students who are experiencing this combination of traditional and scientific knowledge systems. In order to negotiate meaning in science classrooms, young students should be given this opportunity for these discussions, and teachers need to encourage these discussions about conflict between science and culture. Researchers have found that Native American students have trouble integrating Western science and Native knowledge. I think one main factor in this is that students are not motivated to learn the materials in the first place. How interested a student is in the material can have a strong influence on their academic performance. And in fact, students from the Cree First Nation who demonstrated a greater intrinsic motivation to learn were better at integrating traditional and scientific knowledge together. The research that I'm going to talk about today quantitatively and qualitatively explores the intrinsic motivation to learn cultural information as it relates to science education. However, psychometric research is sometimes looked upon unfavorably and disregarded among Indigenous peoples, since the instruments often fail to be culturally sensitive. However, I've done everything I can to make sure that my survey instrument is culturally sensitive, and I'll talk a little bit more about that later on. I included quantitative measurement because I believe that statistical data that shows learning outcomes is important to generate support for this type of education, and there's not a lot of quantitative research in this field. And as I said, I worked hard to make the survey instrument culturally sensitive. The quantitative piece of my study is just part of the larger study, which brings quantitative and qualitative data together to tell a more holistic story that answers the question, is culturally relevant science education engendering motivation to learn? And is this related to how students think about and value traditional knowledge in their science classrooms? So now I want to pause and ask anyone if they have any questions or comments.
Thank you so much, Rose. I'd like to remind all of the participants in the room that if you have questions, to please go ahead and pose them through that chat window. You'll see it on the left side of your screen. There's a little blank window that you can type questions in. But I do have some questions that we received in advance of our webinar today. Rose, you've talked a lot about the literature that you've reviewed with respect to some questions about science education and with respect to some questions about making sure that education is culturally relevant. I wonder if you could talk a little bit about how you came to work on this question and what particularly about science education was it that you found so compelling?
There. Is it on?
And Rose, I'm going to remind you to turn your mic. Yeah, there you go. There you go.
Sorry. Sorry. Okay, so just to reiterate what you asked, you were wondering how I came to this question and why science education. So I have a background in science. My degree is in physics. My bachelor's degree is in physics. And after I got my bachelor's degree, I went into the Peace Corps, and I was a high school science teacher in Zimbabwe. And it was there that I started to think about this idea of having local knowledge versus sort of a Western scientific knowledge. The curriculum there was developed in Great Britain because Zimbabwe was a British colony for a long time, and so I found myself teaching about animals and industrial things that were completely not relevant to the world that my students were living in. And so that was where I first started to think about it, and then I think years later when I was just back in the States and wondering what I wanted to do with my life, I realized that was just a topic that really interested me and excited me, and after looking into it, I found that it's actually a field. I didn't even know that it was a field that existed. So that's what brought me to that.
Well, great. Well, that's a real fascinating piece of backstory. So you have that international take on this as well. I have a question here from James Henry, who asks, what tips can you provide to promote greater use of traditional language within tribal child care centers? And are there any models that you know of?
Thank you, James. I don't have a lot of experience with tribal child care centers, but I am working with, it's called Inkusim, it's a Salish Language Institute, and they have pre-K through 8th grade students, and they're doing language immersion, and they have an elder in every classroom, and I think that's, I guess it depends on the community and how alive the language is, but in the community I'm working with, there are only, I think, 49 fluent speakers left, and so they're getting the elders right in there and you know, using the language, reading them stories in the language, and when I go to that school, I can hear them speaking it, and the little kids speaking it, and it's amazing. So that's all the experience I have with that, really.
Okay, well, thank you, Zach. We don't have any more questions at this time, but I'm going to go ahead and, folks, if you're listening and you have questions, please do post them at any time in that chat window. We'll pause for questions again at the end. And Rose is now going to share with us a little more details about the nitty-gritty parts of the study that she's working on right now.
Okay, so I'm going to talk about my participants a little bit. I recruited students from the Bitterroot, Salish, and Pend Oreille tribes on the Flathead Reservation in Montana, as I said before. There's a little map you can see in relation to where I live in Missoula. It's just, you know, just a few miles north. I'm working with students that are in the 5th to 8th grade, so about 10 to 14-year-olds, and they attend both public and private schools. So as I said before, I'm working with Inkusim, the Salish Language Institute, but it is a really small school, and so they only have 5 students that are in the age range that I'm working with. So I have so far, I guess I want to say also that the Flathead Reservation is a very mixed population. There's a lot of Native and non-Native, so the schools are very mixed. And I have 51 American Indian participants and 55 non-American Indian participants. And then I am trying to work with a balance between students who are taught by teachers that were trained in the Big Sky Science Partnership that I described earlier. And I have 45 of those students, and then I have 56 students who are taught science by teachers who were not trained in that program. Here's a picture of me, and as you can see, I'm not Native at all. I don't think I pointed that out earlier. I think that's an important thing to point out. For those of you who are familiar with the area, this is just at the top of Evero Hill on the southern end of the reservation, and here you can see some of the Salish language, which is printed on road signs throughout the reservation. So in order to do research in this community, I needed to gain approval at 4 levels. Well, 5 levels really, because first of all, I had to gain approval through the IRB at Harvard, which you know, is something that you have to do for all social research. But then in the community, I needed to gain approval at the tribal level. So I went to the culture committee meeting that they hold every month, and I talked about the research topics and questions that I wanted to ask the students, and And I was, after meeting individually with 3 or 4 of them, I was able to get approval through the committee. So it was kind of a few months of going to these meetings and trying to get to know people. I also sought approval from the Kootenai Culture Committee, which is a 3rd tribe that lives on this reservation. But I didn't receive approval from this committee. And although I was disappointed not to have the opportunity to work with their students, they were very respectful and kind to me. And I can understand their hesitation in letting me work with their children. They explained that they're uncomfortable with the idea of having their children's impressions about culture recorded on paper, sitting in a book in a library somewhere, and that it was worrisome that this type of information could be used against them someday. And these ideas are really important to think about and be careful about when you're doing this type of research. Next, I gained approval at the school level. So the public schools have what's called an Indian Education Committee, and it's made up of parents and teachers. And I removed some questions, changed some wording based on some of the feedback that I got from them. Third, I collected parent and guardian consent forms, which are typical, again, for social research studies. And then the last approval is the students. So the students could choose for themselves whether they wanted to participate and whether or not they wanted to answer all the questions in the survey. And I tell them that before they take the survey, that if there's anything that is offensive or they just don't want to answer, they don't have to. And some of them have left some of the questions blank. So now I'm going to go into the design of the study. Again, the main research question is, do students who learn in science classes that include local traditional knowledge, values, and language have motivation to learn about science and culture in different ways than students who do not learn this type of science? There are 2 parts to this study. The quantitative portion focuses on how motivated and interested students are to learn cultural information about the environment. And the qualitative interview explores student ability to integrate traditional knowledge into their science lessons. The survey asks questions, again, about program components that motivate students to learn culture as it relates to environmental science. The survey was developed using the Intrinsic Motivation Inventory, which is a general intrinsic motivation measure. And the blue rectangles show the intrinsic motivation constructs that the survey focuses on, so interest and enjoyment, competence and self-efficacy, and value and usefulness. And through conversations with teachers, educators, and elders, 6 subtopics, which are going to be appearing in the green ovals, and then the questions themselves that are under those subtopics were agreed upon. And these subtopics explore the following questions. So questions about traditional plants and traditional stories explored student interest in learning cultural knowledge related to the environment. Questions about language and science skills focused on how competent students feel that they are in these topics. And the subtopic of reciprocity and sense of place explored how much students value learning traditional knowledge about the environment. And again, the goal with this instrument is to create a valid measure of intrinsic motivation with questions that are culturally sensitive and appropriate to the community. So to give you a little bit more of an idea about each of the subtopics, and more specifically what I'm trying to measure with the questions in each subtopics. The traditional plant focuses on how interested students are in learning about the locations and uses of native plants that are culturally important to the local tribe. The traditional stories questions ask, do students enjoy hearing and learning about the local traditional native stories? Do students think they are competent in learning the local native language? Do they think they are competent in learning science skills like observation and identification? Reciprocity focuses on, do students value the idea of balance in nature, this idea of taking from Mother Earth and then giving something back? And then sense of place. Is it useful to learn about the cultural meanings of local places and the attachments to those places held by the local Native people? And here I'm going to show you a couple of questions from the survey so that you can get an idea of what they look like. The first one here is about traditional plants and asks, how much do you enjoy or not enjoy learning to dig and gather bitterroot plants? Notice that the questions were asked in a balanced way, so a lot of surveys like this that you'll see might just say, how much do you enjoy learning to dig and gather bitterroot plants? The current research in these kinds of surveys shows that it's better to ask it in a more balanced way so that it's not leading the participant one way or the other. Also, the answer choices are on a 7-point Likert scale with an option on the right to choose I have never done this. So when I gave the survey to the students, I read each question out loud, and I really stressed that they should choose the answer on the right if they've never done this activity, and I didn't want them to be guessing. And that way I got a good idea of how many of the students have done these activities or not. The second example here is in the reciprocity subcategory. How valuable or not valuable is it for you to learn about responsible hunting and gathering? And I want you to notice the distance between the answers, so the so-called distance between not valuable at all, a tiny bit, kind of, somewhat, mostly, very, and extremely valuable. That's something that I pilot tested with 5th graders. So 5th graders were the youngest in my study, and I wanted to make sure that that these answers had meaning to them and that I was using words that made sense, and that the distance between the answers was also as close as I could possibly get it. I also pilot tested the language for each question. I asked them, is there anything that doesn't make sense? So do you understand what this question is asking? So that was really important to do before I actually collected my data. So now we're going to look at some of the preliminary results. And this graph is showing us the culture classrooms versus the non-culture classrooms. So the y-axis here, it says Likert scale mean, represents the mean intrinsic motivation scores. So the higher on the y-axis, the more intrinsically motivated the participants are to learn the topic. And then the x-axis represents the 6 subtopics that participants were surveyed on. So you can see plants, stories, language, science, reciprocity, and sense of place. So the purple participants here are the ones that are in the culture classrooms. And then the green bars represent students who are in classrooms where the culture is not integrated into their science lessons. And this graph shows us that students who are taught in classrooms with teachers who have been trained in integrating culture into their science content are significantly more motivated to learn about the first 3 topics: traditional plants, traditional stories, and language. So you can see the asterisk above the plant, stories, and language, and that indicates that there's a statistical significant difference between the 2 groups of students. Okay, and then this is looking at American Indian, so they're self-identified. They're self-identified as American Indian students versus non-American Indian students. And again, the y-axis represents the mean intrinsic motivation scores. And the higher on the y-axis, the more intrinsically motivated the participants are. And then the x-axis shows us again the 6 subtopics that the participants were surveyed on. And the blue bars in this one are the students who self-identify as American Indian. And the red bars are participants who do not identify as American Indian. And from here you can see that the American Indian students are more intrinsically motivated to learn all of the subtopics except for science. So this doesn't mean that the American Indian students are not motivated to learn science. It just means that there's not a difference between the American Indian and the non-American Indian in the subtopic of science. And the last graph I'm going to show you, it focused on enculturation. So in the survey, I also measured how enculturated participants claimed to be. So enculturation refers to the extent to which ethnic and cultural minorities have retained their indigenous or traditional cultural norms. And for each topic subscale, students were asked whether they had personal experience with the topic and if the topic was ever discussed in their homes. So let's just say with the plants questions on the survey, before they were asked any of the survey questions about plants, I asked them if they had personal experience picking and with using traditional native plants. And then after the survey questions, I asked them also if they had any of these experiences in their homes. And so level A indicates that students had both personal experience and experience in their homes with the topic. Level B indicates that students have experienced it personally, but not in their homes. And level C indicates that students have not experienced the subject matter personally or in their homes. And as you can see from the bar graph, students who have personal experience and families that discuss the traditional information in each subtopic, so level A, which is the darker orange, they also have the highest level of intrinsic motivation to learn each subtopic. And then additionally, those students who have not had personal experience with the subject matter and not had the experience of it in their home, so level C that's represented in the yellow, for the most part have the lowest mean score for intrinsic motivation in each subtopic. So next I'm going to talk about the qualitative interview a little bit. And with the interview I'm trying to answer the following questions. How do students incorporate traditional cultural knowledge into formal mainstream science education? And do students value traditional cultural knowledge or think that their science teachers value it? I used what's called critical incidents, and these are stories that incorporate both scientific and traditional knowledge, and they're used to inquire about students' perceptions of the nature of science. And the critical incidents that I focused on, I did two, and one was focused on the Bitterroot plant, and then the second one was focused on local geological places and scientific formation versus traditional names and the cultural information about those geological formations. So the participants, I'm going to tell you a little bit about the critical incidents about the Bitterroot and go over some of the responses that the students gave. The participants were told a story about a little boy who was told a traditional story about cultural practices related to the Bitterroot plant, like the story that I told you in the beginning of this presentation. And in addition, he was given some information about the Bitterroot plant that he learned from a science textbook in school. And then I asked the students, should both kinds of information be included in a report in your science classroom about the Bitterroot plant? And you can see here that student 1 said the books wouldn't tell you what they really used it for. They just tell you information that really isn't important. The book wouldn't have where you can find it or information you might need or might be helpful. And student 2 said books can get things wrong a lot. When he talked to his grandfather will probably know because he has probably been to the ceremony a bunch of times. You can see that there's some patterns emerging. So here I've underlined these two students have a kind of a mistrust or a disbelief in the information that's contained in the books. And these two students I want to point out are from culture classrooms and they have level A enculturation. And then student 3 said the traditional stuff is not science. I would call the story an Indian belief. Beliefs are different than science unless they can be proved. And student 4 responded, the traditional story about how and why it grew probably wouldn't be accepted as science. Traditional is just beliefs, I think, mostly. So again, there's a pattern. Both of these students are calling traditional knowledge beliefs, indicating that they don't believe that they're true or that they somehow value it differently than they value what they consider to be scientific. And these two students are from non-cultural classrooms, and they have level B and C enculturation. So I'm going to show you responses to one more question. The students were asked, are both kinds of information science? Student 1, well, the same kind of information, but what they were saying is different. I would say it is earth science, but I don't know about the feast. The ceremony is not science. It is a confusing question. And student 2 says, I don't know which one to believe, because I guess that they are both kind of true in some ways. Because that could have happened. It could have happened either way. So here you can see that these two students are a little bit unsure. They clearly value the traditional knowledge, but they're not quite sure whether or not to call it science. And then student 3 says, probably the stuff out of the book is science because geologists could have wrote them and it's testable maybe. Or you know that it is a fact, and if you really wanted to, you could look and make sure that it is a fact. And student 4 responds, the parts that I would call science would be the petals, the roots, the pollen. Oh, that's kind of hidden, sorry. Because those are the 4 parts that it mainly needs. These students are more focused on the information in the textbook being science and don't mention the traditional information at all in their responses. So in conclusion, I'll summarize my findings so far. There are statistically significant differences between groups that are emerging from the data. So the students in the culture classrooms versus the non-culture classrooms, students with different levels of enculturation, students who self-identify as American Indian versus students who do not. There are also patterns emerging from the interview data. And this tells me that students in culturally related classrooms seem to be more intrinsically motivated to learn certain topics related to culture in their science classrooms. And they're also showing patterns of thinking about science and culture in different ways than students in non-culturally related classrooms. Additionally, participants in culture classrooms appear to be thinking about traditional and scientific knowledge in more integrated ways. That's all I have so far. I'm still, as I said, I'm still analyzing the data, and so there's still a lot of different tests and things that I'm going to do and different variables that I need to think about. But that is what I have so far, so thank you very much. And as I said before, here's my email. Feel free to email me if you have questions that come up after this session.
Well, thank you, Rose, so much for all of that information about your study. And we do have a couple of questions that have come up and also some really great comments that people are putting forward in the chat here. And I do encourage you to continue to put forward your comments and any further questions that you have. I'm going to turn first to a question that we received before the webinar began. And you had made some remarks about when you were working on the culturally sensitive survey instrument that you had involved some of the community elders. And so this question says, what have you learned as far as culturally appropriate ways to involve elders and their traditional knowledge in the classroom? My experience is that elders do not always readily volunteer the knowledge they might have.
Yeah, so from the literature that I looked at did talk about involving elders in education, but it didn't really talk about how to do that. In my experience and from what I've seen, I've just tried as hard as I can to involve myself in the community, to go to these meetings, even when I don't have a question or things to say. I just try to go to these culture committee meetings as much as possible. I get invited to cultural ceremonies and gatherings, and I try to involve myself as much as possible. And that is true for some of the teachers that I am working with that are not Native as well. They, like I said, this teacher meets and has coffee with an elder at least once a week or as often as possible. And I think that helps to build these relationships and to gain trust and to, in my experience so far, I've seen that they're recognizing that I care about this education and I care about the community, and that has sort of created this relationship where they open up and talk to me about it. So.
Okay, the next question, the next question comes from Nina McFadden, and she's interested in what kinds of questions did you remove from the survey questionnaire based on the suggestions of parents and teachers?
Okay, yeah, so the one that comes to mind immediately is speaking of having assumptions and being careful about assumptions, I had included a question about smudging in my survey, and it was in the traditional plants section, and it was something like, do you enjoy, how much do you enjoy or not enjoy gathering plants to make smudges? And in one of the Indian Education Committee meetings I went to, they said, we don't do smudging in this community. And it was interesting because other people said, well, yes, we do. And so there was sort of a conflict in whether that was something that was traditional to the tribe that is there, or if it was something that was brought in from other tribes. And so I just got rid of the question, and that was purely from me working with other native tribes and just assuming that that was something that happened everywhere. So that's a good example of why it's important to run these questions by multiple levels of teachers, elders, parents, teachers, and other educators.
Wonderful. We have also a couple of observations that participants have shared with us in the chat. So I'm just going to read those aloud, and maybe, Rose, you could react to them or maybe follow up with them. They're not exactly questions per se, but I think there's some very valuable observations. So Juliana Mares notes that she has an outdoor education center where scientists are paired with traditional leaders who present various concepts to students who move from station to station. The kids learn, and so do the presenters, and she notes that this builds mutual respect between the traditional leaders and the scientists and the children, I would assume. And then Juliana also notes that she's seen Bitterroot used to clear and protect the throat of traditional singers. And then her next observation, which I think is nicely put, if you lived in Rome, would you not study Romans? People who have lived on the land for thousands of years may know something about it compared to newcomers to the community.
The information about I don't remember if you said it was a summer program, but I think that's really great, and that's actually the type of work that I am interested in pursuing in the future. So I would love to have a conversation with you about that in the future. So thank you.
So Susan observes that comparing Indian to non-Indian students seems to perhaps neglect any interest non-Indian students may have for an Indian perspective. I imagine that even non-Indians may have some knowledge of the Indian perspective and might at least be a little sympathetic. In other words, I wonder just how different these students who sit side by side or live close to one another really are. Or would you expect a city student to have even more different views? So Rose, I wonder if you could say a little bit about the interest that you've seen from non-Indian students in these traditional practices.
Yeah, so that's it's always sort of touchy when you start to compare Indians and non-Indians, and I haven't quite decided how to handle that yet. I think it does bring up some interesting ideas, and I definitely want to try to focus more on the classrooms that have the culture versus the classrooms that don't, because that's the main part of my study. But I've definitely seen, non-Indians that do have an interest in the culture that they're living in and that they're surrounded by.
And just to clarify there, by the classrooms that have the culture, you're talking about the classrooms whose teachers have been through that Big Sky Science Partnership Program. Is that right?
Yes, that's correct. It doesn't necessarily mean if they haven't gone through that program, some of the teachers are still putting some of the culture into their lessons. But what I'm focusing on is this program in particular, which is a more intensive and longer training where they're learning, not just content, but also methodology, and have these partnerships with elders and this continual process of learning more about how to do that in their classrooms.
So I think we have time for maybe one or two more questions. So I'm going to take Marilyn Lowe poses the question. The question about science, could you share your perspective of what is science and how that influences your thinking about your research?
Yeah, that's a really tough question, and it's something I think about a lot. The slide that I talked about, traditional knowledge, and this quote from Gregory Kahete, I really feel like observations that are made over thousands of years, I think traditional knowledge is definitely science. You can get into different debates about particulars of different kinds of traditional knowledge, and I'm thinking about the stories. Traditional stories, are those science? And I think that I sort of go back and forth about that, but what I'm really trying to focus on right now is what the students think and how the students value it. I guess on some levels I feel like it doesn't necessarily matter if it's science. I think what matters and what I'm focusing on is how the students value it. Do they feel like the information from their culture is important and valuable, and is it something that's going to make them want to know more about it and more about how nature works in the world, and hopefully make them want to go into the sciences and become scientists themselves, so that they are the ones that are making decisions on their reservations about natural resources and land management with the solid cultural foundation.
Okay, so next question, Dr. Felon asks, regarding the comments from the non-Indians who speak to Native knowledge as quote-unquote beliefs, she would like to know, is this due to their understanding of science or their lack of understanding of culture, and perhaps it's even a combination of those?
Yeah, I would say that it's probably a combination. From the data that I've gathered, it's kind of hard for me to know that. I guess it sort of ties in with what is science and that whole thing. So I would say that I think it is a combination of both. But I would need to talk to them more and expand the interview to really understand why they're saying that their beliefs and what that means to them exactly.
Okay, I said two more, but I have one more that I would I wonder if you have some perspective on. So the question is, how are you giving back or sharing these results with the particular communities that you're working with?
Yeah, that's definitely something that's on my mind, and I haven't finished my study, but I do intend to give presentations to the culture committee as well as to the tribal council. I've been talking to different people, trying to find out what is the best way of doing that. I also want to definitely involve all the teachers as well in the presentation if they're willing. And so those are some things that I'm thinking about. And my hope is to actually work with the community, later. I really want to do more of this kind of work, and I want to get some funding somehow to do more programs, more summer camps and after-school programs and that type of thing.
Well, thank you so much for sharing all the information about your work and your work in progress with us. I'd like to thank all of our participants for attending. The webinar archive will be available on Incella's website, and you can see at the bottom of the slide is the link to our main webinar page. You'll see the webinar archive within a few days. It'll appear on that webinar page. So again, thank you to all of our participants and to our presenter for attending our webinar today.
And thank you everyone for joining us. I appreciate it.